right, calculus, here we are for your section 2.6 notes video. This is day 3, so it's going to be final day with limits involving infinity. So these look very similar to what you're going to see on your homework sets and what you might see on a quiz review and quiz. Okay, so it says find each limit if it exists. So we got the limit as x approaches infinity of this is f of x, the square root of 7x to the 4th plus 2x plus, or divided by 3 over 2x squared. Which, when you have limits involving infinity, you can write it in a sort of equivalent and approximate fashion. So this is approximately, the limit as x goes to infinity of the square root of, in the numerator, what's the highest power of x? That is x to the 4th. So that's the one that really, really matters here. All right, we saw that when we divided everything by the highest power, the denominator, which is x squared, which in the square root would be x to the 4th. This would essentially become 0 if I did that. This would become 0. So what I'm doing is I'm only looking at the highest power of x in the numerator and denominator. Okay, I'm not dividing everything by something. I'm simply saying that is the most important term in the numerator. That's the most important one. And the denominator, as x goes to infinity, that's going to carry the most weight. Again, we did this very early on when we divided everything by x to the 2nd. 3 over x to the 2nd as x goes to infinity is 0. If I divide this by x to the 4th, because the square root of x to the 4th is x to the 2nd, this is 2 over x to the 3rd, 0. This is now 0, that's now 0. So I'm only looking at the term with the highest power of x in the numerator and denominator. That's what, again, that's not exactly equal to, that's why we're using, the approximately symbol there. All right, and now this does exactly equal. This is exactly, if I take the square root of x to the 4th, that's x squared over root 7 divided by 2x squared. What's going to happen? The x squared is going to cancel. It's because the highest power of x was in the numerator and denominator. Okay, so that is the horizontal asymptote rule. This is the second one, when the highest power is in the numerator and denominator. It's the same highest power. Then it's going to be the ratio of the leading coefficients, root 7 over 2. All right, so that is the answer, root 7 over 2. Next one, the limit as x goes to infinity of x over, the square root of x plus 3x squared divided by 4x minus 1. This is essentially just like number 1. This is approximately, and this is how I want you to do it, double tilde there. This is approximately the limit as x goes to infinity. What's the most important factor? Up top, it's 3x squared. What's the most what's the most important term? We're not going to share this video widely. What's the most important term up top? That's 3x squared. What's the most important term in the denominator? That's 4x. Now this does in fact equal the square root of x squared is x root 3 over 4x. What's going to happen? The x's cancel. All right, and you're left with root 3 over 4. Awesome. All right, here is example 3. The limit as x goes. A lot of anesthesia involved in my surgery. All right, so if I mispronounce, we had a pretty more intense surgery than I expected, I think, on Friday. The limit as x goes to infinity of the square root of that minus x. This is so similar to number 16 on your homework set number 2. Hint, hint, wink, wink, which at the end we'll talk about because I will do 2 of them with you. And then on Wednesday and Thursday, you will get some very good notes to help you finish this. All right? So I'm going to multiply the top and the bottom, because this is now over 1, by the conjugates of this. So the square root of that plus x. I'm going to multiply a root by itself. What is inside the square root just falls out. That is x squared plus 4x plus 1. A negative x times a positive x is a negative x squared, which the x squareds will cancel. Gives you this. And this is approximately like this. Again, what's the most important term up top? 4x, and these are both important because what's most important inside the square root is x squared, and the square root of x squared is the same as x, so these are both of equal importance in the denominator, both this and this. Okay, what is the square root of x squared? It's x plus x. I did a few of these in the Monday video, I believe. Monday and or Friday video. X plus x is 2x. The limit as x goes to infinity, well, this is going to cancel. 4 over 2 is 2. Again, that is so very similar to number 16 on your homework sets. Number 2. All right, so take a look here, and it tells me, so write down this one. The limit as x goes to negative infinity. All right, again, what? And I gotta grab my Chromebook. I should have had that ready because my mobility is not quick. The lovely Rover scooter that was a prime sponsor of Yak Math videos starting in the Friday video is now in much use. So we will have the Chromebook ready here. So I have the limit as x goes to negative infinity. Of the square root of 1 plus 4x squared over 2 minus x to the third. Again, what is the most important term up top? It's that. What's the most important term in the denominator? It's that. So that's why I say this is approximately the limit as x goes to negative infinity of the square root of 4x to the 6th divided by negative x to the third. Again, we showed this all this work why it was like that essentially when we did these the long way. Okay, again, we're going to look at the graph here in a second, but sorry, Chromebook. So when I do this, the square root of 4x to the 6th is 2x to the third. What's going to cancel? You might think that your answer is a negative 2, right? You might think that the answer is a negative 2, but if we look at Desmos here, and Desmos is going to have the graph of, I'm going to look at it as x goes to infinity as well. So there's the function. Desmos is so great, much better. You know, our graphing calculator is great, but this can get just any window we want. So I type in the function there, and you can always type in the function down here. Just gives you that. It's awesome. Really, really good. Anyway, as x is going to negative infinity, that's the sign right here. Y is going towards what? It's 2. Y is going towards 2. So not negative 2. Actually, when x approaches positive infinity, it's going to negative 2. So it's kind of opposite of what, I mean, we literally just got 2 over negative 1, right? But let's look here. Go back to the original numerator. Go back to the original. All right, what comes out of this can only be positive. What comes out of this can only be positive. I mean, plug something that's going to negative infinity close to here. If you raise it to an even power, it's going to be positive. So this is going to be a massive positive, right? And if you plug a negative infinity or anything massive and you cube it, this becomes a negative and you're subtracted negative. So that's why this is essentially a positive. If you let x go towards negative infinity, this is going to be a massive positive number. This is going to be a massive positive number. Positive over positive means that's why we get a positive 2. Now, I'll give you ones that are a little bit more clear, okay? This one right here, again, if we do this, why did I say it's equal to negative 2? I didn't do that up top. Why did I say that? Again, if we go back to the original, what comes, well, no, I shouldn't have done that because it's not negative 2. So forget about that. Again, wait. Sorry, we clearly saw that it was negative 2 up there. All right, so why is it a negative 2? Why can I accept this answer? Why can I look at that arithmetic and go, oh, it's 2 over negative 1, which is a negative 2. Why is that allowed here? As x goes to a positive infinity. Well, if x goes to a positive infinity, it's clearly going to be a positive number. And if I, again, think of 10,000, 10 million, if I cube it and stab it with a negative, it's going to be a negative number. So I get a massive positive number over a massive negative number. That is why it's going to give me a negative 2. Again, what comes out of here always has to be positive. If I let this be 10 million, 10 billion, it's going to be a massive positive number. That is now stabbed with a negative. Up top, if I let this go to be negative you know, 10,000, negative 100,000, negative million. It's a negative number that gets stabbed with another negative, which makes it positive. Again, yours should be easier to understand. Don't worry too much about those. We know it's got to involve 2 or negative 2. Okay, that's the important thing. Being able to do this, say this is approximately this. That's the most important thing. All right, so here's what I want you to do. I want you to, because I've changed the due date, you guys are going to email me this homework set, because I would imagine I will be out, not this week, but I'm definitely out through next Tuesday when I see my surgeon again. So I want, send me this homework set so I can grade it then on Monday. So do numbers 1 through 12, 16 through 18 on your chapter 2 homework set number 2. Okay, you can do those today, you can do this tomorrow. We have a new due date. You're gonna scan and email me this homework set by 9 p.m. Sunday. All right, it's, you know, it's due what do you guys like 13 hours earlier now? All right, so you can do others. You can do 1 through 12, 16 through 18, and I'm gonna help you with a few actual ones, and I'll help you with another tomorrow. And I will give you the notes on Wednesday and Thursday for equations of the tangent line. Make it pretty similar to your homework one. So this is the new due date. You're gonna scan and email me just like you did honestly the previous 2 years. Okay, again, if you have that iPhone, the notes application is fantastic. Try to get this all in one document. Some of you last year sent me like 8 different photos, which is fine. But again, if you have the iPhone, it's very easy with the hit the notes application, and there's something at the bottom. You can take a photo. You can make a really nice photo, and then you can, you know, it's like, I think it's a scan documents. Anyway, I'll make a video. Again, if some people need it, I will try to make a video. Anyway, it's pretty easy. Ask around. Some of you guys did a really good job with that last year. Again, if we can avoid sending me, 6 photos, that would be nice. Let's try to do that. That would look a little more collegiate, sending it in one. All right. Thank you. Now, with that, let's take a look. Some chapter 2 homework set number 2. Homework help. This is number 3. This is actually number 3 in your homework set. The limit as x goes to 2 of that function. So what are we going to do? We need to get that root out of there. I have a 0 over 0 situation. That is indeterminate. So I need to multiply the top and the bottom by the conjugate, root x plus 2 plus x. Multiply top and bottom by that. So up top, I'm going to have x plus 2 minus x squared. And at the bottom, so here's what I've done. I have factored this. These both have x squared in common, so I took out the x squared, leaving me with x minus 2. Again, I factored this. And then here's the conjugate. Okay, so over here, note the following. That what you have in your numerator can be written like this. And I can take the negative out so that the leading coefficient is positive. We always want that. So now it's x squared minus x minus 2, and this factors. This is x minus 2x plus 1 with the negative sign out. So, write note off to the side. So now this equals that. There's a negative sign. And I have the x minus 2, and that's what needs to go bye-bye. The x minus 2 is the problem. When the x minus 2 cancels, like it does now I can plug 2 in for x. All right, now I can plug 2 in for x. You can pause this whenever you need to. There's me plugging 2 in for x. Pause it. There we go. And we have negative 3 over 16. So you're welcome. That was one of the hardest ones. And you got some help on that. And lastly, for this video for Tuesday, the last one here. Let f of x equal that piecewise function. All right. We just said that's number 1, that's 2, that's 3. You had a bunch of these in college algebra. Evaluate each limit if it exists. The limit as x approaches 0 from the left. So what does it mean to be on the left side of 0? It means to be less than 0. So I'm plugging 0 in for x in that first equation. So I'm going to plug 0 in for x. 2 minus 3 times 0 is square root of 2. The limit as x approaches 4 from the right. What does it mean to be the right side of 4? That means you're bigger than 4. That is equation 3. So I'm going to plug 4 in for x there. 4 minus 2 is 2. Square 2, you get 4. All right. That is your notes video for Tuesday the 19th, and we'll just keep rolling like this. Obviously, when I get back, I'll answer any questions and do a big review, but this is going to hold us steady and keep us relatively on pace while I'm out. This is Yak Math Videos, signing out.